Hi, everyone. So great to see you here. Thank you so much for joining us today. We're just going to give it another 30 seconds for people to come and join us this afternoon, or this afternoon in the UK. I know we are being joined by people from all over the world. As you can see, my name is Mel, and I'm really happy to see you here. This is our first live stream ever. So this session will take approx 40 minutes, give or take, and we will open to questions at the end. However, if you're signed in, you can start typing your questions in the live chat like you've been doing so far. We will get to them at the end. If you guys have to leave early, don't worry, there's going to be a recording of this session. And I would love to introduce you to the team. So we have Mel, as you know. Jason's going to be dealing with questions later on. Clayton will be introducing Skylark. Alistair is going to tell us what WikiHouse is trying to do. And Gabriele is going to do the super exciting science bit. So without further ado, I'm going to hand over to Alistair.
Cool. Thanks, Mel. And good afternoon / morning, evening, everyone. This is very cool. Let me start by doing the compulsory bit where I just work out how to share my screen for a moment. There we go. There we go. Cool. So I shall rely on you to shout if that's not working at any time. So yeah, it's just really cool. I mean, I think as you've probably sensed, this is something that we've been working on for a very, very long time. And I think one of the first things is like, many of you sort of appearing have been kind of involved in the WikiHouse community for ages anyway. So I think we kind of the first thing we have to sort of open with is an apology, really, and a thank you for your patience while we've been working on all this stuff, and we'll try and give the best account that we can to sort of explaining why and what really. It struck me a while ago that we've been working. It's been 10 years since the first the first experiments on the first kind of WikiHouse kind of project, which like makes me feel a bit old. And over that 10 years, that like it's been on this slow journey, really, from going from an idea to a real thing and to a kind of mature reality. And I'm incredibly proud of like all the cool things. Like we love seeing all the cool things people have done with WikiHouse. Like with it, like incredibly proud of the fact that even early on, it's an idea that it wasn't like our idea in a way that we started it. It was just sort of immediately, it's an idea that clicks with so many people and so many of you, because it's just something that should exist, right? But also that kind of recognition about the sort of, the 10 years, 10 years since the first experiments, 6 years since we really kind of started working on it. It was also kind of tinged with a frustration, really, because even though, on one sense, we felt incredibly frustrated that we'd moved slowly, or it felt like it'd been this slow journey. Like even 10 years later, WikiHouse is still innovative. And that's weird. It shouldn't still be innovative, right? It's sort of somehow, however slowly we might think we may have moved, somehow the industry has contrived to move even more slowly, in the sense that buildings are still huge. I mean, they account for 28% of all carbon emissions in their use and 11% in embodied. Now, sure, embodied carbon in use is hard because it involves retrofitting existing stock, etc. And there's lots of interesting stuff. But that 11% embodied carbon, we could be reducing that right away, and we're not doing it, right? So, and the same across pretty much every metric. I mean, all of you are here because none of you this is not news to any of you, right? We know that we still have a massive shortage. We're still building incredibly poor quality housing. We have a massive shortage of affordable tenure homes on things like public land. Buildings are still huge contributors to the single biggest source of material consumption. and so on and so forth across pretty much every metric, right? We don't need to spell these out. Upshot is we're doing collectively really, really bad at transforming the way we build for the 21st century. And one of the things I always find weird about this is that actually the strange thing is that most of us agree on what it is we want, right? On what it is we're trying to achieve, right? We're trying to build beautiful, zero carbon, zero waste, leafy, green neighborhoods with generous, warm homes that are kind of prosperous local businesses, great community infrastructure, these kind of neighborhoods that are great places to grow up and to grow old. Like that's something that pretty much, I mean, nobody disagrees with that. And yet, for the large part, we're not doing it. And it's not because we don't have the knowledge. The knowledge is already here, in the words of William Gibson. The future is already here. It's just not very well distributed yet. So we have the knowledge. We kind of have the collective will. Now, so the question is, why not? To some extent, the answer to that is to do with incentives, right? It's complex, right? And this is a big part of some of the other work that Open Systems Lab are doing, is looking at things like how we can redesign our land system and our planning system. But actually, to a huge extent, what should tell us is that because there are examples, right, that it gets through, and what that tells us something, right, which is if you go and speak to those kind of groups, right, who are building homes, and I should say, right, a lot of, despite the complexity of all the reasons why we're not, a lot of it does boil down to a really simple thing, which is essentially to do with incentives, right, which is that there is an essential truth at the center of the built environment, which is that the best people with the best incentive to build the types of zero carbon neighborhoods that we all agree we should be building are the people who are going to live there. And yet, in most of our current housing systems and the housing systems we inherited from the 20th century, that's the one group of people who have almost no power and no control in building and shaping lives. Like the control over who develops is massively centralized. And what's really interesting is that when you do find examples, this is, this photo here is a great example. This is a co-housing development in North London, right? It's called Older Women's Co-housing, who have done it. And you say, well, why isn't it's so obviously great? Why isn't this happening everywhere? And they will all say basically some version of the same thing, which is it's too damn difficult, right? It's incredibly difficult to kind of, sure, to get your hands on the land. But even once you got your hands on the land, it's really difficult to know how much things are going to cost to attract finance, et cetera, et cetera. So there's an essential there's a central idea, if you like, behind WikiHouse, which is really like, what can we do about that? That's the kind of question that we're trying to ask. So what I want to quickly do is to run through three kind of big ideas that I think are the three driving ideas behind how WikiHouse might be able to kind of help with this. So the first thing the first idea is make it simple, right? So there's a kind of this is that kind of great Buckminster Fuller quote about if you really want to change something, don't fight against the existing system, build a new system that makes it obsolete. And one of the best ways we can do that is just make it much easier. It's such a simple, obvious fact that if we want more people to be able to do a thing, let's just make it easier for them to do that thing, rather than it always being the difficult option. And so in what way can we use design to make it as simple as possible? And that also, of course, has other secondary benefits of allowing more people, right, democratizing the capacity to take part. And that's, of course, where we come back to wiki. So we're all familiar with the word wiki as a sort of kind of web language for open and collaboratively edited, which it is. But the original meaning of the word wiki comes from the Hawaiian, which simply means doing stuff quickly. So that's also a kind of one of WikiHouse's agenda, is to say, like, how simple can we make it to build, basically, to build really good zero carbon homes. And this was obviously something that was playing heavily on our minds with the previous version of WikiHouse Wren, because it was cool, it was a great idea, but in practice we'd said, right, okay, we've made the bit where you can assemble a house quite easy. But the truth is, it was really obvious to us as we were kind of working with others using this system, that the rest of the process really wasn't easy at all. Right? The system was really hard to design with. Pretty much every design had to be kind of custom and bespoke, and that also meant that it was really hard to document as well, really hard to share files. And Clayton will talk a bit more about how Skylark changes that. But then it was really hard for engineers to understand in each case, etc. Then on site you ended up with this stack of this kind of hundreds and hundreds of parts that you had to sort through and store. So when we looked at the whole picture, we were really aware that actually our job isn't done until the whole thing looks something more like this, right? So this is our kind of ambition, to say, how can we make the entire process as simple as possible? And really the objective is this, right? Let's take this in itself will not end the housing crisis or anything like that. But what we can at least do is take the idea that building zero carbon homes is difficult off the table. Let's make it so easy that any business, any community, anyone can do it, and everyone knows that they can do it. Let's just move ourselves, and that's really what we're trying to do, trying to move ourselves into that kind of future as quickly as we can. The second big idea is obviously the one about kind of manufacturing. So in the last few years, there's been huge kind of progress, I'd say, push forward, particularly in the UK, around moving towards more manufactured models of building, which is cool, right? It's dragging construction sort of, I would say, into the 21st century, but at least into the 20th century. And generally speaking, when we're talking about off-site manufactured homes, you're talking about something that looks like this, right? These huge factories that cost many millions of pounds to set up, and that's cool, right? These are really impressive facilities that can turn out, several houses a day at least, right? So really impressive, but they also have real issues with this model. So it's good for some things, but it's not good for everything. It's particularly good for large-scale projects, large-scale supply chains on big sites with a much more standardized product. But of course, that's not true of all development, right? Lots of projects aren't big projects. They're small projects on small sites that are slightly customized. There's also they tend to be less resistant to sudden like spikes in demand and also downturns, and that's historically been the most challenging thing for this model of highly centralized manufacturing, is that you get a downturn in the economy and you have this amazing capacity but no demand. And so obviously the other kind of big idea about WikiHouse is began with this idea of, well, wait a minute, if we can make a building system that is can be manufactured in a really small scale factory, which has a really small setup cost, it can be started, you can have local small businesses manufacturing these components, and collectively this network of distributed manufacturers can form an industrial capacity which can at least match, but potentially in many ways even be more effective, not necessarily as efficient, but more effective and more flexible and more resilient. And that is a kind of a cool vision of manufacturing. So let's actually make that real as a kind of manufacturing approach. So maybe the kind of housing factory of the future doesn't only look something like this, it can also look something like this. And I know a lot of you have manufactured wiki houses in spaces a bit like this one. And so that's a really big part of the work, that when we're working on Skylark, we haven't just been thinking about designing the thing, the end product, the end houses, but designing the whole process and really thinking through the kind of the economics of space and really trying to optimize that. And again, Clayton will talk a little bit more about that, but kind of this idea of the shifter blocks was trying to make sure that we do a little bit more of the pre-assembly in the manufacturing space as the sheets come off the machine. So yeah, it's designing a process as much as designing a product, and then open sourcing that. And there's a lot more that we're going to be learning about how to kind of standardize that and do quality control. And yeah, so this idea that in many ways it's never really been about making houses, or it has, but it's really been about building capacity. Like, we want to build economic capacity, because once you build distributed local economic capacity so that all businesses everywhere can build zero carbon homes, that beats building just one company. And that, of course, leads us seamlessly to the kind of third objective, which is make it open source. Because again, like, what's really funny about open source is when you say, oh, kind of, we're sharing all these files, is that people look at you like you're mad, like it's this sort of act of altruism. But we don't think it is, right, actually, necessarily. First, because like nobody owns the IP of the brick, right? Nobody needs to, right? It just belongs to everybody. But also right now, is even if we took this distributed ecosystem, what we have is loads of cool people coming up with really, really good ideas, right? Really cool building systems and stuff like that. But those solutions are locked behind the limited bandwidth or capacity of just one company. So we say, well, actually, isn't it potentially more exciting and actually more effective to say, what if all those businesses are kind of, if you like, drawing from a shared common pool of knowledge, and then all sharing their feedback back into that common pool of knowledge. So on one sense, it looks like, oh, you're giving away knowledge for free. But in fact, what you're actually doing, of course, is recruiting an R&D army, basically, of you know, hundreds or thousands of people. And of course, you know, so many people have contributed little bits and even just bits of feedback to WikiHouse that has got it to this point. Yeah, where it is today. And so, yeah, building in kind of, and we're kind of particularly going forward, you'll see Mel will talk a bit more about this. We wanted to make it much easier to kind of share and improve and version the files, but actually also not just that, literally just capturing feedback is really valuable. So if you're using WikiHouse and you see an opportunity to improve it in even the smallest way, or you see a bit on the website that's not working, and a lot of people have already been doing this, it's been fantastic, just grab a screenshot, go to WikiHouse feedback and send it. Yeah. And I guess also, you know, this is also an interesting point to kind of confirm. So when we are showing you, you know, as Clayton's about to show you Skylark, everything that we're showing you is not us going, here's this great thing that we own, right? What we're saying is all of this belongs to you. So there's a whole bunch of companies who I'll kind of give proper credit to at the end of our kind of session this afternoon. But a whole bunch of companies and organizations have collaborated on doing loads and loads of R&D behind Skylark. And they all did that not in order to own it, but because they wanted to use it, because they wanted it to exist. And so, yeah, to the extent that Skylark is of any use, it belongs to you. And with that, I'll hand over to you, Clayton.
Hopefully you can see my screen. Yeah, so that brings us onto Skylark. And it's less of a dramatic reveal because it's been out there on the website for the last few weeks, and I'm sure some of you had a chance to play around with it and at least have a browse. But the benefit of, well, we've got to a Skylark is we've got this benefit of sort of 10 years of prototyping and R&D and experimentation and actual built pilot projects to draw on, and that's given us some sort of key lessons, and it's been informed by the work and input and feedback of so many other people out there, and various WikiHouse teams and hobbyists and manufacturers around the world. We wanted to make sure there was also, it wasn't just an evolution technology, there was actually answering some sort of critical key questions that we had about making it, I guess, relevant and making sure that it actually ticked the right boxes in terms of what it needed to do. So the first big one is to make sure that it was carbon negative, that it did more than just be neutral in terms of its carbon impact, that it was actually actively a carbon sink. So at an embodied carbon level, we are we're actually sequestering 17 tons for an average 2-bed house of carbon out of the atmosphere, and that's all baked into the structure and materials. And in comparison to not traditional masonry, that's a massive difference. And we worked with Leeds Beckett University recently in a report that you can find on our website. And they looked at the whole, the lifetime carbon emissions over 100 years, including embodied carbon emissions and also end-of-life emissions. And over that 100-year life cycle, it was half the amount of the total carbon that you would find if you went down a more traditional construction route. So that's a big change. The other thing I mean, this is particularly looking at a European context, but that it could meet most housing needs, and that the basic blocks within the library would be able to do the types of low to medium rise residential housing and small offices and small workspaces that we see most of the construction in Europe is. That library will be expanded on, and there'll be bigger spans and more form options, more types of roof and things like that as we go. But we also we want to make sure there wasn't too limiting in terms of design, that you could build the types of projects you were doing already, particularly in terms of mass housing, and switch that across to Skylark rather than going down less sustainable routes. And a big aspect of this is something really looking into the future is that instead of just using materials once and they go to the building, if you make a change to the building or its use ends, the building then gets demolished or has to be retrofitted dramatically to become relevant again, that you could actually reuse and recycle large portions of the building structure. And not just the building structure, but everything else. So it's looking at making sure that the structure itself, the way it interfaces with other materials, means that things could be mounted and demounted. The structure itself could be reused on another building, or in the very end of life case, if there was, it had to be retired, that you could recycle it as well. And there are some downstream companies here in the UK that will take used plywood and turn it into chipboard that can be used on other building products as well, which is really cool to see. So we want to make sure that there's that long-term view built in as well. It's circular to begin with. And it has to be easy to learn and also really quick to build. So easy to learn for designers who want to take it and work and create designs and hopefully beautiful architecture and create neighborhoods with it. And then it needs to be easy to understand for a build team, for whoever's working on site, be they volunteers or professionals or existing contractors who are used to working with traditional methods, to say, okay, this is something new and different, but it's different that it's not going to take me on a 3-month training course to be able to get up to speed with. It's something I can work on within a day in terms of how parts fit together and learn really quickly. And that massively reduces the build time. So we're looking about at least half the time on site. So the labor costs are less because there's less labor work involved, and parts of most of the stuff is being put together. Either it's being cut to fit in size, so you have to do any cutting, but it's also being put together in a workshop environment before it's really arriving to site. So there's less work outside in the weather and the elements, and then looking at heating bills as well. Because this is a particularly big one at the moment, is that obviously the cost of energy has increased so much that we really have to be much more mindful than we have ever been in terms of the efficiency of the building fabric that we're constructing, to make sure that it is as efficient and as draft free and doesn't leak heat, and that over a year it's going to save you hundreds of pounds. And as well as the hundreds of pounds, you're also saving lots of carbon and lots of energy that would be otherwise expended in a sort of equivalent minimum building regulations building. So that's a massive difference. And then the most important one probably is that it's great to have all this stuff, but if it's going to cost 3 times as much, it's not really going to go very far. So we want to make sure that the materials and the manufacturing processes and everything that goes into it is coming out at least cost comparative with other methods. And there's a range in there. Obviously, it depends on the types of specifications that you want to have. We did have some questions back on an earlier presentation of this, is what's actually in these costs. So these are superstructure build costs, so everything that's not including the land, design fees, and things like landscaping and stuff like that. It does include a sort of basic foundation if it's quite a simple site. Obviously, it's a more complex site that's not. But and that's not just the structure, that's how to clad, that's everything to clad it, windows, doors, fit out, that kind of thing as well. So that's the sort of cost range that we're operating in. Obviously, you can go higher than that if you really want to go sort of all in, gold taps and all that. But for most projects, this will do. And so what is Skylark and how does it work? If you've been to the library, you'll see we've taken what was WikiHouse in terms of a sort of language of connections and joints and really sort of intricate CNC joinery, and broken it down to really standard building blocks. And these building blocks all are built they come off a CNC machine, and we use, as there was a question earlier, we use an 8 foot by 4 foot, 1.2 by 2.4 meter bed size CNC, because that's also the sheet size of the plywood that we're cutting. I mean, you could do bigger, but these are sort of standard off the shelf products. And from there, we can machine the parts. As Alistair alluded to, we tried to create the system in a way that while it's machining another part, you can then be assembling the part that's just been cut. So you're not sort of doubling up on effort there. And these cassettes, in this case it's a wall cassette, gets filled with an insulation material. We tend to favor a soft fill material like a rolled, like a loft roll, which there's some really good products coming out in the UK. One is using recycled polyester from plastic bottles. So it's the same sort of stuff you get inside your jackets and coats, but it's being used to insulate your house. And that's really cool to see. So, and that's get all built up. I mean, the machining time for something like this is probably looking at less than an hour to machine these 2 sheets to make this block, and then 15 minutes to put it together, and then you've got a section of wall. And so, because we know we can make quite accurate predictions and get feedback from manufacturers in terms of how long it takes to machine and what the cost implications are, we can work out very quickly what a standard cost of a block might be. And once we know the cost of a block, we can work out how many blocks are in your house, and very quickly you can work out the cost of what the house is going to be. And you've got this pricing information at your fingertips to begin with, not something that you've created a design and then gone through the whole sort of tender process and you get to the end and then it's too expensive. You can actually you can know what the likely cost is. It's a good estimate cost at the very beginning. Yeah, so in terms of the build-up, and I'm sure I can take questions about this later and go into more detail, but the whole system is designed to sit on foundations, and it doesn't really matter what those foundations are. We talk about being foundation agnostic, where you can have screw piles like this. You could have a concrete strip foundation. You could sit it on even a concrete pad, where you actually just cut out the base structure of the Skylark. So there's no timber floor, it's just sitting on a concrete floor and build up from there. There's quite a range of options you can take, and obviously it depends on the type of site, the ground conditions, what engineering requirements are there. And the first Skylark elements you place down are what we call combs, which are these sort of vertical connectors, horizontal connectors, but they stand sort of vertically locking together, and they form a sort of base beam that it gets fixed to your foundation using fairly standard steel brackets. We'll have some more details about this coming on our website soon. Once that's in place, that's sort of a guide for then placing your floor beams on top. So this standard Skylark spans, there's a range of them. We've borrowed language from clothing sizes, so you'll see this extra small, small, large, extra large spans. And then an end beam as well, which is where your sort of perimeter end wall sits as well. And all these are pre-insulated. They fit together. There's these interlocking bow ties that tie the structure together. And then it's a case of dropping the wall blocks in place. And this all happens really, really quickly. It's sort of difficult to convey until you see it on site, just how quickly you can get a structure up, because all the hard work has been done for you by the time you get to site, really. And it's really easy to go and tap these bow ties into place, and you've got quite a rigid structure, that doesn't need any sort of propping up as well. I will add, there's also some pegs that go in the bottom here, which connect the combs to these wall blocks and help to sort of daisy chain the whole structure together. As you can see, there's another layer of combs when you're building upwards. Then you can build walls, including gable end walls with different pitches. That will all be coming shortly. And add windows and openings where they need to go. You can top off the roof. The roof comes in 2 sections that get put together. We try and look at sort of innovative ways to try and do all the roofing without needing to have external scaffolding. So they can be raised from inside the building and sort of positioned into place. We've got some, we've got some details on possible assembly routes for that. We'll put them in the guides as well. And after that, once you've got your plywood structure, you can very quickly wrap it with a waterproof membrane. And then that will give you a basic watertight shell. And once you've got your windows fitted, you pretty much built a weatherproof structure that you can then work inside of. That doesn't make any difference to having done it on a factory floor or out in the elements. And yeah, I'd say that the time from doing it on from foundations up to this point is we're probably looking at 2 weeks, right, for a 2-story house. And then you can go on and clad and line it and finish it how you want. Because you've got an 18mm plywood substrate, you can fix battens to wherever you want to put battens. You can put your vertical cladding on. It could be timber cladding, it could be sheet metal, it could be terracotta tiles, you name it. Anything ideally that's sort of a dry fixed product that is going to be quite quick to install, doesn't require any specialist skills, just a screwdriver and a bit of elbow grease, and from there you can then make it look like whatever you'd want your design to look like. It's really, we leave that bit up to the architects really, and run services and things inside as well. So the blocks, without having the structure behind me just to point at, but the blocks themselves have a service run built into them, both in the floor beams and in the wall blocks. So it's deep enough to take a electrical socket pattress box. And you can run all your cabling and stuff through those voids, and you don't need to put battens on the inside because it's already has battens built into it. That means when you come to do your drywall or your plastering or your flooring or your ceiling, you can just go around and screw this into place without have to cut battens first, which I think really sort of speeds up that process. And really makes it easier. So here's a very quick little video. This is sort of 6 months or so ago now, where we did some structural testing at BRE, and we built this full-size 3D module in the BRE structures lab. We've done a few sort of prototype builds since as well, but this is sort of just a very quick idea in terms of the speed it does to put up those wall boxes, and then we spent a bit of time fiddling around with the existing base frame that we're working with, and putting the floor blocks into place. And again, positioning windows and things like that. You've even got the option to, if you want to you got on the site and you decided the window was in the wrong place, to move that into a different location without sort of radically needing to change the design, which is quite nice. So if you go onto the WikiHouse website now, you can find all this information. I'm sure many of you already have, but you can go into the block library. You can find details on what all the blocks are, including specification info, so sizes, heights, weights, embodied carbon for each of them. You can download them as a range of different CAD formats, which we will be expanding and trying to find more sort of common platforms that meets the needs of designers and anyone who's using it. Or you can even go, if you're a real nerd, you can go into the GitHub and you can actually contribute issues. You can download the models. You can create forks of these versions. If, for instance, you felt like the roof pitch wasn't quite the roof pitch that you wanted, and you wanted to have a go at I guess, re-engineering it to meet your needs. And if that's a really useful fork and it's going to be useful to other people, we definitely invite you to sort of try and share it back with us so we can actually merge it into the main library as well. And then to help support people doing projects with WikiHouse, this is a big missing part of this in the past has been sort of lack of documentation and guidance. that translates a lot of the expert knowledge that people who've worked with WikiHouse before have into something that most people can understand, or any new professional coming to this can understand. So we try to break it down by the various trades. So architects and designers, there's a specific guide for you for showing you how to design with WikiHouse, what the basic elements are, how you might go around detailing things, and what you can do with it. And then for manufacturers, particularly if you're a new manufacturer, you've got a CNC workshop and you're interested in making WikiHouses, you can, there's quite a good guide there with details in terms of the space requirements you need, the types of bit sizes and tooling and yeah, all that aspect. If you're interested, it's and it will be, some of these will require a few sort of graphics images to finish off, but hopefully they'll be quite intuitive to follow. And then there's a general assembly guide as well, which is the one that's sort of got the most questions marks at this point. As we build more projects, we'll learn more about the sort of site processes and how you deal with within certain regulatory health and safety rules and things like that on site. And also just the general order of construction and how do you manage the logistics of delivery and of parts and what sort of size team you need, training you need. And then for each block, there's an assembly guide that's in the block library. And then for each project that gets built with WikiHouse, will have its own sort of dedicated assembly manual as well, which is separate to these guides. Yeah, so that wraps everything up that I was going to talk about. I'm going to pass on to Gabriella, who's going to go through the details of how the structure works and what makes it really actually stand up, and yeah, can go into a lot more detail about the physics behind it as well. So I will pass on to Gabriella.
Thank you very much, Clayton, and good day, everyone. So I would just like to start this presentation talking about how lucky we have been, because finally we had the chance that happened after 10 years, that we had the chance to actually bring WikiHouse in the lab and test it to understand the structural properties, so we can sort of provide scientific evidence about how the system works. And this is one of the modules that we built for the last exposition that we had in London. And what I would like to do in this presentation, just share with you some of the lessons and some of the things that we have learned in the last few months with respect to the structural properties of Skylark. So I would like to just guide you through some of the elements that compose WikiHouse, and the first one is I would like to talk about is actually the column, one of the column forming the walls. And this is one of the first elements that we had the chance to test. This is a picture that we took at Edinburgh University, and we were doing some testing on columns in compression. So the yellow element you see on the right side is what we call an hydraulic jack. It's basically a little machine that you can pipe oil into, and this element is trying to extend, and because it's reacting against the column, is putting the column into in compression. So we're trying to break the element and see how much force it takes, so we can have a sort of feeling. And it was quite interesting, because it was one of the first tests that we were doing on the system. So we have a sort of an educated guess of how much force we could have put into the system. So based on that, we decided to take that specific hydraulic actuator, which can take around 10 tons. And when we were carrying out the test, it was pretty cool to see that our educated guess was not very well educated, because we pretty much broke the ramp before breaking the column. So that's quite good from a product perspective, but I can assure you, when you're in the lab and you see something being compressed at 10 ton and things don't go really quite the way you think, it's not as fun. But basically what we did is we just took a bigger one, and is actually pretty cool to see what happened after, and I will show the video the test at the end of the presentation. But if we just go as a flash forward to the results, basically we were able to put 140 kilonewton into the column, sort of an average out of the 4 or 5 specimens that we did, which, if you're not a structural engineer, might not tell you much in terms of numbers, but just to get you a feeling, it is equivalent to the load of not 1, not 2, but 3 elephants, one on top of each other, provided that you manage to stack them that way. So it's a pretty decent amount of load that you can put into a timber column. This is cool. This is the column, but obviously, if you think about a building, before reaching the column, the load has to travel through the beam before going into the column and then into the foundation. So that the beam is one other element that we managed to test. And before going into details, I'd just like to share, those of you that might not know much about structural engineering, what are the principles behind the beam. So you might be familiar with traditional solid beams, especially classic timber beams made of some timber are rectangular. And the way they work, when they start working in bending, you have the top fiber of the beam which start working in compression. So if you imagine your beam trying to bend, the top fiber start working in compression, and the bottom parts start working in tension. So when you use a material that you can customize a little bit more, for example, steel, you potentially don't see solid block elements, and the reason is because you try to put the element where it's working. So the typical shape for steel is the I-beam shape. So you're putting the material on the top and on the bottom, because those are the fibers that are working. And you also achieve another effect, that you're removing dead weight, you're removing mass from the part of the beam that is not contributing much. So a steel beam made like this much more performs way better than if the same beam was a solid block. And that's the same philosophy we try to apply to scalar beams. So we have this cassette that where the material is placed in the flanges in compression and tension. So we try to optimize the properties of with the same property of the material, we actually can achieve a better performance. So in order to understand the properties of Skylark beams, we took them into the lab. Again, this is a picture, some of the tests that's been done at Edinburgh Uni, and we were applying a vertical load. You can't see much, but there's an actuator behind the red column, which is a slightly bigger version than the one I showed you before, with the only difference that this actuator is controlled by the computer. So we can actually have a little bit of better control on the loading protocol that we apply to the specimen. And you see that the specimen is painted white, and there are some cameras on the right that are tracking the specimen. I will show a better picture after, but one of the things that we do normally in research is that we paint our elements right and we draw some dots. So we are able with cameras to pretty much track the dots that we draw, so we can have a much better understanding of what's going on into the structural elements. I will show you something later on about that, which I think might interest you. So we carry out the test, and basically we were able to put quite a bit of load in this timber beam. And if we look from a distributed load perspective, this is equal to 5.8 kilonewton meter, which again, if you're not a structural engineer, might not tell you much, but just to give you a feeling, this is equal to the load of 2 cars, or if you prefer, is actually equal to the load of 3 walruses. It's pretty funny because we started this walruses drawing mainly like a joke, but we actually found out that there are some projects for building some modified version of WikiHouse in Antarctica. So I'm very much looking forward to see a real picture of real walruses on top of a Skylark beam. So I talked a little bit about the beam, I talked a little bit about the column. The other element I would like to talk to you about are the walls. They are not really an element. We call them sort of assemblies because they are made of more blocks. And this is some of the experimental setup that we use to test the elements at BRE, which is the British research establishment. And basically what we were trying to do is that we build this assemblies, and I don't know if you can see, but on the top right there's a sort of a steel column, and between the specimen and the steel column there's another actuator. So we're trying to push the load horizontally to simulate wind loads and trying to see how much force it takes before breaking. There's also some vertical loads which are applied with some steel tendons that are running through and then get attached into the lab, and that's some sort of the way we normally try to simulate the load coming from the floor, because we want to test the wall in different loading conditions. So, for example, if that represents the load at the wall at the first floor or at the ground floor or other configurations. And what you can see on the right is actually what I was trying to say before. We tend to paint our specimen white, and then we try to draw these black dots. And we use a technique which is called digital image correlation, which is basically means we are taking sequential pictures of our specimen while we are introducing load into that. And by using some algorithm, we can track the displacement of any one of these dots. And this has given us a lot of information, a lot of insights about where the displacement occur, where there are strain concentration, stress concentration, and it gives us a good understanding how the structure will behave. So the main conclusion of that test, that all the results are actually in our website, but the main conclusion is that we test the wall with different type of openings, and walls with solid walls are more stiff and stronger, whereas the more openings you put, the more your element becomes flexible. Not necessarily, it becomes also less strong, a little bit weaker, but not that much. And is what is really governing at the moment is the flexibility criteria. So what does it mean? It means that when we are building one-story houses, that's fine. There's the amount of load that the wind is going to try to push your structure is not, doesn't create any concern. But as soon as we start going, for example, in 2 stories with the current structural detailing that we have, even if the structure is completely safe and there's no concern from the capacity point of view, the structure might flex a little bit too much. So with the current structural detailing that we have, we need to limit a little bit the amount of openings that we can recommend. Well, this is our current solution. We are actually working on it, and our goal is to move towards a situation where there's no limitation in terms of creativity, in terms of amount of opening for 1-story buildings and 2-story buildings, and then we push any further challenge, any other more cumbersome, maybe technical solution to 3 stories and above. Now, before going to the last part, I'd just like to show you one of the experiments that we carry out at Edinburgh Uni. This is a test, the second round when we were testing the column, and you can see here now the structure is about to go, and this is the sort of failure which we had, which was quite cool. It was a sort of a buckling, local buckling in one of the panels near the med span. So the last thing I would like to just quickly touch about is that all the testing that we have done, walruses or non-walruses, we try to translate all the information in something that is quite meaningful for structural engineers. As Clayton was mentioning before, designing these sort of structures might be challenging. You don't know all the interaction between all the panels, but hopefully what we try to do and hopefully we are doing is to provide enough information for structural engineers to actually design the system with much more confidence. The idea you can have some experiment done that show you the failure mode, that show you how the structural works, should be a little bit more give extra confidence from a design point of view. And also, this is not all, but also we really want to provide scientific evidence. We have there's some papers that we've written. One has already been published, one is currently under review, because we really want to provide scientific evidence about the actually how Skylark work, and to provide data that is actually a good system and it performs the way it should. So with that, I just want to thank you, and I will bring the word back to Mel.
Sorry, Mel. You're on mute.
Hi. Sorry about
There you
that.
go. No worries.
Let
So
me,
I'll just remove myself then.
Okay, so we are, sorry about that. We have heard a lot about the product, WikiHouse, a product, and I'm sure you have lots of questions. So I'll just take a couple of minutes to tell you a little bit about where you come in, because I want to talk to you about people. WikiHouse Skylark is for everyone. So wherever in the world you are, whatever level of expertise, if this is your 20th WikiHouse or the first one that you're building, we want to make it as easy as possible for you to build with Skylark. So what can you do next? Build with it. So Clayton already mentioned that we have a library of blocks using something like SketchUp, for example. You could be building this if you wanted to with the blocks that are available. You just need to download them and start building straight away. We also have a page called Start Your Project, where you can find different bits of information and guidance, for example, a design guide. But also you could ask us to help you with certain services that we've designed. So we can come at certain points in the process and help you with, say, chassis design or structure checking or manufacturing assembling. But we are not doing this in isolation. We have got some listed manufacturers, listed providers on our site already. And my second request is become an on-demand provider if you would like to. So to do so, simply visit wikihouse.cc/providers. If you're a manufacturer, an architect, an installer, or an engineer, you can apply. At the moment, we are only limited to the UK, but if you are not in the UK, you can join a wait list for this. And then finally, just continue to contribute. We've heard in the last 5 weeks since launch a ton of feedback. which has been great. That we need so many eyes on this, right? We need to know what things are working, what things are not working, and the only way we can do that is with your help. So ways to contribute are joining the Slack community. I know there's loads of you here. I've seen you as you were joining in. So great place to meet other people who are working with Skylark, with WikiHouse all over the world. We will put the links to join Slack on the site in a minute. As Clayton said, you can submit feedback either through GitHub directly, you can fork things through GitHub, or you just use a feedback form on this page. And maybe submit a new version. Maybe you're going to make some improvements, create new blogs. We would love to hear from you if that's you. And if you have the means to test, again, Gabriele will be really happy to hear from you. So contact us, please, if you're able to test. And now it's over to you. WikiHouse is for everyone. So we're really glad that you joined us today. We are going to go over to our Q&A now. So I'm going to hand over to Jason.
Thank you, Mel. So, and thanks to everyone who has posted comments and questions onto the comment section. So what I'm going to do is I'm going to read out some of the questions. And if we're running out of time and we don't have the time to actually answer the questions, don't worry. We're going to compile the rest of the questions on the list and post them on our Slack community channel. So let's dive in. So there's a question for you, Clayton. It's from Jennifer and Jerry. What is the expected timeline for the release of the remaining missing blocks? For example, the flat roof, sloping roof, skylight windows, and stairs.
Very good question, and what a question. At the moment, we're doing this alongside other stuff. So I think part of the plan is that we'll be releasing a new block once a week, and we'll try and build up that library rather than doing a big bulk upload of everything at once. I think that might be more useful, just get stuff as and when it's ready and you can use it. There's the question of whether I think we'll go down the route of getting the Skylark 250 to a point where there's a good range of design options there, a good range of roof forms. This has to go hand in hand with some sort of engineering pre-work as well, to make sure that what we're putting out at least has some validity to it, that it's been sort of, I wouldn't say checked, because that we'll go through a full testing with it, but at least we know we can provide some information in the engineering guides that corresponds with the blocks that are in the library. But yeah, the plan is to focus on those missing roof sections and maybe looking at spans and also window options for the 250 series. And then once that's at a sort of stable point, we'll move on to doing a Skylark 200 series as well for smaller structures.
Thanks, Clayton. Moving on. Oops, sorry. Here's another question for you, Clayton or Alistair. What do you expect Skylark to come out of beta? When? Sorry.
I mean, we don't really have a goal. One of the ways that we've sort of worked is, I'm incredibly proud of the fact that we just kept working in the open, kind of keeping it open source. And one of the things about that is that we always know the direction of travel, and we always know what the milestones are, and we don't exactly know when we'll get there. So we sort of, for us, the next thing to happen with Skylark is that we've sort of, as you can seen from Gabriela's thing, we've spent a lot of happy hours crushing bits of it with large, expensive bits of hydraulics, which is fun. And we've built quite a few prototypes, but we still haven't built the first live projects. The first one possibly should be going on site in April, maybe. But, go. Let's see how quickly we can do those. So I think for us, that's the real test, is to get to a point where we feel confident that it's sort of we've sweated all the issues. So we know that we'll find ways of improving it. And ways of improving the documentation from the first pilot projects, really. So that's the next thing that's got to happen, is building a bunch of projects with it. And then at a certain point, we'll get to the point where we say, yeah, we're happy, we're confident that this is a kind of mature project. But of course, we're not going to stop improving it. We're always going to be iteratively improving it.
Cool. Thank you, Alistair. So there's another question for Gabriela. How do the Skylark beams and column strengths compare to traditional timber, 2x6 or 2x8 or 2x12, etc., levels or steel beams or columns?
Yeah, that's a very good question. So the comparison is a little bit tricky to make because it depends which sort of timber system you're using. It depends if you're using Glowlam. It depends if you're using traditional timber frames, or if you use something different. Similar thing. So that's with respect to timber. So it's a little bit tricky. When we talk about steel, steel is stronger. That's true. Is definitely stiffer and stronger. So you might be able to pretty much to take the same amount of load. You can have a steel column that is thinner. I think what we are trying to achieve with this particular system is that we can make sure that we can cover the spans that you might need in a typical house. So between, I don't know, 5 point something to 6 meters, and that's what we are really targeting. So to make sure that the system that we are providing can actually do very efficiently the job that we're asking it to do it. The fact you can solve the same problem with perhaps a steel beam, that's true, but that's at the stage what we are trying to do. Yeah.
Great. Thank you, Gabriela. A question for you, Mel. How does the WikiHouse team intend to promote and grow awareness of WikiHouse?
Hey, I'm not mute. Sorry about that, guys. Thanks for letting me know that I was mute. I can see the comments now. Yeah, so we want we want to have things to show. We want people to build with Skylark. So please let us know if you're planning to build, especially this summer. I've heard already of a couple of potential projects, and we want to know what you're finding hard, what you're finding really easy, how you're getting on. Doesn't really matter what stage your plans or dreams are at. Honestly, just email us, chat to us through Slack, whatever. Just be in touch. We'd love to hear that, and we'd love to tell the stories of what's happening as well. Yeah, I can't say too much just now because things in the pipeline, so they're not quite there yet. But as soon as we have something, we'd love to show that, and just tell the story of how it's gone.
If I may, on the kind of as a general arc of it, one of the kind of interesting things that, like, there's always been more demand in our experience since we've been working on this. There's always been more demand to work on WikiHouse than there's ever been the ability to actually meet that demand. So that's our main priority. So when you say, well, kind of, I mean, you quite like talking about raising awareness, but we actually have never ever sort of gone out to consciously sort of market or advertise it, because there just hasn't ever been a need. I mean, maybe at some point there will become a need, but there just hasn't been a need. So our immediate kind of strategic priority was first to get a great system. So, I mean, without wishing to kind of bore you all, like, you can probably read into the arc of the last few years, we kind of arrived at a point where we were developing WikiHouse iteratively, project to project, working with whoever was building with it. We got to a point about 2 or 3 years ago, we're like, right, if we were to take everything we've learned and throw the whole thing in the bin and start a new system, how would it work? And that was the beginning of Skylark. But in order to do it, we needed to get this opportunity. It involved this structural leap, which is the way that the beams work. And in order to validate that, we needed to structural test it to check that it was kind of real. And we didn't really want to kind of put out sort of files into the world that might be dangerous. So that's why we've spent so much of this initial part of the effort in improving the system, the product, if you like. And there's still lots and lots of improvements that we're going to be doing to that, but particularly, as Gabriela mentioned, in many ways, in terms of gravitational loads, as you can see, it's kind of over-engineered. Like, you know, no bit of wall ever needs to support 3 elephants. Like, it's just not a thing. But our issue is about flexibility with wind. That's very much the issue with things. So we know we've got a structure, a building system that's really kind of performs incredibly well, is incredibly strong. But we'll be working on lots of little ways we can improve the product. In terms of giving designers more flexibility when it comes to where they can put openings, in terms of, you know, making the thing easier to make, easier to build with, easier to ship, and etc., etc. But so that was the first phase, was get to a point where the Skylark system is a product that is a good system, and we're going to keep improving it. But the next phase is growing that network of businesses who are using it, and that's why we're doing this experimenting, exploring this idea through the beta of building this network of on-demand manufacturers, so that it becomes incredibly easy to connect people who've got a site and want to build with whatever help they need, and it's as much or as little as you want, to do it, right? So that's our next thing, is to kind of build that supply chain, if you like, to build that capacity. And part of the work, the sort of hidden work behind the surface of that, is now that Clayton's doing, is sort of making sure that you can get a mortgage on that system and things like that. So that's the next phase that we're going into now. For sure, there might then be a later phase where we say, right, we're so confident in that we've got so many suppliers now that we actually do want to drive demand, and we'll kind of cross that bridge when we come to it. But yeah, it's never ever been a problem. There seems to be so much need that this fulfills. There's so many people who want to build, and they want a predictable, easy, zero carbon, high performance building system. So I think our really work is to make sure that it exists, and that there's companies, a network of companies there to supply it.
Thanks, Mel and Alistair. Another question for you, Clayton. It's from Jack. So he's interested to know our thoughts on plywood prices at the moment. So they have clearly increased massively. So he's interested to know your thoughts on future pricing versus conventional mats, given like 1,400 till 2,000 per square meters.
In pricing, I mean, maybe not the last couple of weeks, but it's obviously a factor, but unfortunately it's a factor that's affecting all materials in construction at the minute, plywood being an acute case. But I think this is why we need to find efficiencies and everything else. And plywood's not the be-all and end-all of WikiHouse. Other materials are available and definitely worth exploring. We did test some OSB beams and wall sections with the University of Edinburgh earlier on, and I think there's still some possibly viability there in other products as well, or some sort of hybrid approach. But the main thing with the plywood is to try and use it as efficiently as possible, and that's where Skylark betters other versions like Wren, Blackbird that we did in the past, just in terms of amount of sheets per square meter overall that it uses. And therefore, it's even though the prices have kind of gone up since those projects, overall the amount of material we're using is less, so it's offsetting that. But there's the cost is a complicated thing, because it's not just the product cost. There's all the sort of manufacturing costs and deliveries and logistics as well. And I think Skylark really improves on that, and that's going to be a big difference. And also the elephant in the room is the rising labor cost, how expensive trades are getting. And by reducing the time on site, reducing the specialist skills involved, it makes the labor factor much less. You need less people around, and it takes less time to do it. So as that continues to climb, as we expect it will do in the future, WikiHouse costs will stay fairly consistent on that. So I think we're heading in the right direction, but yeah, we're at the mercy of global supply chains like everyone else is in a minute.
Cool. And following that, sorry, I apologize if I'm mispronouncing your name. Ruarith. So he's wondering if Skylark 200 will be available soon, because he's planning to build this summer and finalizing the plans.
Yes. Yeah. So as I sort of mentioned before, it's a bit sort of chicken egg. We want to make sure we've got enough understanding of Skylark 250 before we translate that into a slimmer system. But the Skylark 200 library will be less less involved than the Skylark 250 library because it's designed to do smaller buildings. So there'll be less range of things. But at the moment, I would say middle of the year would be a good estimate for when that would be available. But yeah, until some of the other things are out of the way first, it's hard to give a definite date for that.
And following on Alistair's comment on warranties and mortgages, so Rebecca is asking if we've considered insurances and self-built loans to fund the projects, and what's beyond that.
Yeah, so it's, I mean, Clayton, I mean, I don't want to answer for you, Clayton, but yeah, the basic backdrop is for this is that if you want to get a mortgage in the UK, certainly this is, if you want to get a mortgage on it, then you'll need what's called a warranty. In practice, a warranty is actually 10 years of defects liability insurance. So that is it's a very tangled web, those things in the UK. But our first plan is to get, we've been obviously in conversations, we've been using a couple of insurers before with projects using WikiHouse Wren. So obviously Skylark's a lot better. So we're reasonably optimistic that will be on the short term. We'll be able to say, right, we can get them on board, but it will have a slightly higher premium cost per house. But over time, hopefully by we'll kind of look to standardize that and to get more product certifications so that the kind of warranty cost per project will work. But I think, Clayton, is it fair to say that it will be possible to use a mortgage now?
Yeah, I mean, with this WikiHouse projects have been built already that have mortgages and have got structural warranties, so I don't see that being a massive barrier. It's just to try and do that on a blanket sense where you almost guaranteed that that if you're building WikiHouse, you'll be fine to get a mortgage as long as your design checks out. Then that's the sort of future we want to work to. So we are having these conversations at the moment with various mortgage providers and insurers and warranty companies to try and sort of lay the groundwork for that. At least in the UK, other countries deal with this differently, and some don't have as stricter requirements. So, yeah, I can't comment much on outside the UK at the minute. But the testing data and some of the certification stuff we'll have to go through will hopefully be translatable into other regulatory contexts.
Thank you. Yeah. So here's a question. Are there any plans in motion to build Skylark homes in the next years? So I think I can help to answer this. Yes, definitely. So we currently actually have a few projects in the pipeline in the UK, and I think we'll be expecting the first Skylark build end of April. But not only this, basically without relying on the services on the website, we really encourage everyone to actually do it themselves, to build their own Skylark homes. And yeah, so basically you can share with us what you've learned with the community, and so we can continuously improve the system together. So the more the merrier. Moving on, question from Rebecca. Would there ever be a WikiHouse retrofit edition for extensions, decarbonizing and modifying existing homes? Or is the idea that the system could be adapted for retrofit too?
Yeah, I mean, I can take the start of that. Yes, definitely extensions. Absolutely, we've seen WikiHouse extensions in the past using Wren. It seems Skylark even makes it more straightforward because it's easy to have a sort of concrete base that is the same level as the rest of your house and flows nicely in from there, and you build the Skylark structure on top of that. The retrofit to existing structure to sort of super insulate or something like that is not currently in our sites, but it is definitely an opportunity with something like WikiHouse to do a sort of retrofit option of own individual system that works, that could work with existing buildings. I'll leave that up to you guys to sort of explore, really. It'd be cool to see what happens in that space. It's not something we primarily focused on just at the minute, but obviously it's a huge part of what we need to do to decarbonize. So yeah, very interested to see what happens.
Could we also, because Rebecca also asked another question, which I think is an absolute blinder of a question, which is MMC is a very male-dominated space. How have you overcome the design to ensure Skylark isn't a sexist system? This is a really good question. So, and there's a sort of technical answer, and there's a kind of broader answer. I'll try and quickly cover both. So the technical answer is sort of, is to what extent can this be or not be built into the system? So and this is something we've thought about a lot. I quite like the idea of literally the idea of a sexist system as a kind of way of framing this. So in the same way that we kind of focus a lot on things like mistake proofing, joints and components, you can also think about it in terms of sexist proofing, in the sense that, and particularly the most obvious example of that is that the EU publishes very clear, and every country, but the EU set the standard for lifting guidance, right? So one of the obvious constraints is, can we make a building system where you don't have to be a massive burly bloke and it's all kind of macho for doing that? And as far as possible, that's something we've tried to factor in with the components. So for example, with the wall components, that's going pretty well in terms of the carry. It's a 2-person carry. And it shouldn't, I think I'm right in saying it's fine, like it doesn't matter, it doesn't care. Some of the floor beams, it's not so much. So what you always like saying is like, oh, right, well, your problem is if you say, right, this is a 4-person carry, or 5 people if it's women. So I think there's more to do on that side. I think there's also stuff about, Vincent, MMC is a very, very stupid phrase that's used in the UK called modern methods of construction. It's almost like someone asked their grandpa to give a name to kind of future technologies. Oh, it sounds very modern. So yeah, that's MMC. So the second thing is also to do with the dynamics on site, and I think that's really interesting, is trying to get away from getting things that can be built by small discrete teams rather than this highly centralized, kind of very bossy kind of structure as well. And I think there's things in there that we understand a lot about. It doesn't necessarily directly equate to the kind of sexism, but it's sort of written between the lines a little bit. But the other broader point is about participation, and I think WikiHouse, a community, as people using it, we probably do a bit better than some areas of kind of endeavor around construction innovation. And I think a big part of that is probably to do with the community, if you like, the types of use and the types of groups and the types of incentives and motivations that WikiHouse is used for. So there's a huge number of people who are not in the old school, big old centralized hierarchical businesses, which have incredibly poor kind of gender ratios. It's a much smaller, more distributed mix of organizations, including community organizations, et cetera, where the culture is a lot less male toxic bullshit. But equally, I think all of us are aware that it's still pretty male dominated. WikiHouse is still pretty male dominated. And I think that is something that we need to, we're kind of really very forefront in our minds of in terms of the space that we create and the stuff that we do, the kind of, making sure that the culture of this as a community, etc., it is great, so that it genuinely feels like a space that is for everyone, regardless, And I think, it's really, really important. There's many things about the bullshit old world of construction that we do not want to replicate in this space, and sexism is high among them.
Definitely. Thank you, Alistair. I have another question for Gabriella. What are the odds of simple and small problems in the current releases that have a big impact when building, for example, windows and ceiling heights?
Yeah, that's a very good question. So what we found from so basically when I present you the data is and what we try to provide on the engineering guidelines is the capacity of the elements, so how much load they can take and how stiff they are. when you go into a real design project, you need to combine the capacity that pretty much we're giving you with the demand that is coming from the building code. So let's say you build a house, you pick up your code, and it's going to tell you, okay, this is the amount of load that is going to happen. Or if you build in Sheffield, or you're building in Aberdeen, Scotland, that is the likely wind that is going to happen. So the design normally occurs when you compare the demand with this capacity. So what we found, we just ran some few examples, placing buildings here and there in the UK, and doing some calculation benchmarks. And as Alistair was saying, from a gravity perspective, there's no issues. The way the system is designed is good from a gravity load perspective. From an horizontal load perspective, at the moment, the bottleneck is really about the flexibility of the system. So one of the requirements that you find in the building code is not that your building has to be strong enough to sustain a certain amount of load, but it has to be stiff enough so it doesn't flex too much. The reason behind that is because if you put any sort of particular partitioning or windows, if they flex too much, then you may have some cracks or damage. So that's why you have some limitations in the code. And currently the bottleneck is really making sure that this amount of deformation doesn't occur. At the moment, the only way we have to do it is by limiting the amount of openings. So there are currently some recommendation in the design guideline, and then some more specific numbers in the engineering guideline on how to calculate wind and how to make sure that we can address this limitation. Now, this is for the system at the current stage. In parallel to that, we are working on improving some structural detailing. For example, you're going to see in the website that the way the columns are connected to the beams are using what we call pegs, so some timber elements that just slide in through that. And when we were running the experiment, we basically could see that this when you try to deflect the wall, there's a big displacement occurring between the columns and the timber beams. So one of the things we think we can improve the system is by, for example, designing a second set of columns that can go into the bottom layer that can somehow restrain the wall to deflect too much. We're not really too far from the building code, but still we wanna. There's room for improvement to make sure that we can address this sort of current limitation that we have, which becomes evident when you start building, for example, 2-story buildings that have a specific shape. Try to be as specific as possible, but some aspects are really project specific. The wind that is in Aberdeen is completely different, maybe than the wind you have in Sheffield. We believe there's a good possibility for improvement, and seeing some projects that people are planning to build in Antarctica, it's quite reassuring and cool to see that if a building can take a wind in that region, then there's no reason why it cannot do it in the UK. But yeah, so just to answer the question, yeah, I feel the current bottleneck is really flexibility, and especially when you go with 2 stories and above. And yeah, hopefully we can solve that pretty soon to address this current limitation. Yeah.
Thank you, Gabriela. So here's another question, a general question for anyone who wants to jump in. What are the plans for Skylark outside of the UK?
That's an easy one, because it's up to everyone else, really. We've had some contact and people reaching out to us across the world, and I know there are some groups in Australia who are very keen to do some work. There's a few in the US, but really, if the stuff is out there, hopefully all the documentation's there you need. It'd be cool if someone just goes ahead and is able to set up that local supply chain, find the engineers that they need to work on it, hook in with the manufacturer, and obviously find a client who's connect with the people who want to live in the homes, and have some land, and make some projects happen. Do you want to add anything to that, Jason?
Yes, definitely. Because currently we have, in terms of the services that we provide, the help that we provide on the website, we have 6 different ones, and we have 4 that's currently based for UK customers. So the future plan is to basically to be able to help anyone from around the world with the services. But going back to the goal is to basically encourage everyone to do it themselves. Like if you're really stuck and you really want to speak to someone, we're definitely here to help.
And yeah, Mel, did you have we got some plans for building the network beyond the suppliers we've got listed in the UK?
Yeah, I mean, we have got quite a few people on the wait list. So as I mentioned, there is a wait list at the minute for countries that are not the UK. Unfortunately, there's only 5 of us, so we are focusing on the UK just now. But we've definitely had interest from, as you said, as far as Australia, the US, I think someone in South America as well. So yeah, it's good to know where those points are, and to just get more at this point.
Yeah, basically the kind of critical. It's obviously, as we said, we encourage everyone to just take the files and try and use it wherever you are, right? If it's appropriate to your context, we'll always be the first people to try and persuade people not to use it if it's not. Obviously, that other thing is then trying to build up that network of manufacturers who know how to manufacture it, engineers who know how to calculate it and sign it off in relation to the local legislation. So, as the guys have said, that the immediate thing is, right, let's get that working in the UK where we know there's a certain critical mass, and we know already, right, there are teams. So, for example, Vincent and the whole team at Woningsbouw Atelier, they've just finished building, I've literally lost count, how many houses is it? Like 20 something houses. So we know that there's these organizations who are building up that expertise. So at that point, when we get to where once we think we know enough about how that kind of network can operate really well, it will be about then saying, right, what is the kind of minimum critical mass for a new country? Say, yeah, you've got a structural engineer, at least one structural engineer, at least one manufacturer, in that jurisdiction who know the system, who've used it and can sign it off and can provide services around it. And at that point, it'll be like, okay, that's it. Then we can start to kind of make it reach everywhere, really. So if you're interested in using it, if you're not in the UK and you're interested in doing that, the first thing to do is start experimenting with it, build up that team, get a structural engineer, find a project, make the first project happen, build that expertise so that you've now got that capability kind of ready to go.
Great, thank you. I'm afraid we're running out of time. Our event is drawing to a close. We have one last question. So back to you, Gabriella and Clayton. So what is the reachable overspan for floor and windows? Are there any plans to develop bigger spans?
Perhaps I can start with that. So I think the last beam that we tested had a clear span of 5.4. Is that right, Clayton? In Edinburgh, and when we were working out the calculation, with respect to the limitation given by the code that was ticking the boxes, so there was some sort of over capacity. So the capacity was greater than the demand. I can't remember by how far, but we are thinking that we can attempt to have spans that are a little bit longer. I don't want to bother you with all the engineering details, but we believe that the more we think about the system, the more we have a better understanding of how it works and the way we can actually improve it a little bit. So the answer is we can span at 5.4, and that should cover what we think is the usage for domestic buildings, so residential houses. Now, if you talk about roof, so if you have a one-story structure and then you want to place a roof, we haven't tested yet, but we can probably spend a little bit longer. The reason is because your system is not really working in bending, but as a sort of truss system. So we can probably spend a little bit longer. We haven't run any calculation on that because such calculation not really Skylark specific. We can probably do some sort of base ideas, but they can probably be solved by any type of by any structural engineer, just with the structural properties that we are providing. For what concerns walls, as I was mentioning before, one-story structures should be generally fine. When we go in two-story structures, there are ways that we can currently solve the problem. One way, for example, is instead of just running the pegs, we can think about placing some sort of metal plates that try to bridge that displacement that is trying to occur between the mid-column and the beam. There's nothing that we have tested yet, but we developed some mathematical models to kind of predict what is going to happen, and that can be a possible solution. Other ideas could be, for example, if you use any sort of cladding to your system that is heavier than the timber, that is going to definitely help bring your structure down and increment the stiffness. So there are ways to kind of currently solve the issue, which are not super elegant in the sense that are not super nice, clean, and timber solution that you would do in case of a one-story structure, but there are ways to get around that. So yeah, I think that's the answer for the moment, but we are really hoping soon to do more testing and explore ideas. We have to kind of develop this nice, clean timber solution even for two-story structures.
I would say also, like, there's also a kind of strategic thing here. As you can see, from Clayton was doing earlier, we could do anything, really. It's about deciding, as Cedric Price said, technology is the answer, but what was the question, right? So we've got to decide what's the target. So we set ourselves a series of things that we think, well, if Skylark can do that, it will cover, 80%, say, of most of the needs for most things. So that's why, for example, we haven't focused on the ability to do curved structures or hip roofs, because we're like, well, sure, that's a thing, but it's like, where do we invest our focused engineering is to get to a sort of, call it a minimum viable product, whatever, but a version of it that can do most things for most people. Now, as it happens, we set out to have a maximum span of 4.5 and ended up with one of bigger than that, because it actually does perform better. So it probably is possible to do bigger spans, and maybe your beams will just get deeper as you go. But that's the joy of open source, right? So if we don't do it, take the files and do it. If you see a need to do something that is beyond the kind of capabilities that we're focusing on as a team, it'd be fantastic to go and do it. It'd be fantastic, and then share your work back for everyone. It's why I just love working on an open source project, because people go and do stuff that we never kind of imagine people doing with it.
Cool. I believe that's all for now. So as mentioned by Mel earlier, the event is recorded. So if you're feeling bored or misses us a lot, please rewatch the event. And please follow us on social media, email us if you have any further questions or feedback. So I'll just post the links on the Slack community channel right now. And WikiHouse team, anything else to add?
Yeah, if I may, I'll just finish with some thank yous, really. In fact, what I'll do, I will try and, bear with me, just share my screen again. Share the other screen, this one. Tell me if this doesn't work. Oh, it looks like it. Oh yeah, it is. That's working, right? You can see that. Cool. So first thing, obviously, it's cool. This lot are really, really cool, and there's a whole bunch of other people in the Open Systems Lab. So amazing work by all of them, getting this to this point. And I think it's really interesting. We've seen kind of lots of things come and go, but the power of just persistence and really sweating the problem and patience is just amazing. The The other thing that's kind of worth acknowledging really is, there we are, this lot is, as I mentioned before, you know, what was really interesting is I'm so proud of keeping this technology out in the open. We took this decision to go down the thing where we are a non-profit company, so our job is just to make this the best possible infrastructure for as many people as possible. So we don't want to make one company, we want to make 1,000 companies. We want to make tools for, you know, 1,000 communities, many more than that. So that's really cool. But the problem it gives you, that's not actually a problem when it comes to necessarily revenue, because if you create value, there's usually something around there. But the real problem is capital. And that was a real issue with us, is like, you know, we'd have these investors come bounding up to us saying, right, how much money do you want? And we're like, well, it's not for sale. But it gave us this problem, which is like, well, when we came to do the Skylark thing, where we said, right, if we were to start from scratch and we had this fantastic idea, it then sat still for a long time because we had no way of testing it. So hugely grateful to a chunk of funding from Innovate UK, which made it possible for us to get into the BRE big bunker thing and do all those tests, and to work with the University of Edinburgh, like incredible organizations. And so Skylark is the product of the thinking of many people. You know, that's like, but particularly in these last few months, these organizations have made this huge contribution to kind of make this thing to the point where it is. The other thing, of course, is a huge thank you to all of the people in the community, because partly for all the contributions and just the cool, amazing stuff for the projects, for your kind of shared belief with us that this project is a worthwhile project, that this is a thing that the world needs, and just leading by doing is just incredibly cool. Also, thanks for your patience, because, you know, we know that with our limited resources, we were being really strategically focused on, let's just try and make this thing useful. And that meant that we were a bit kind of rubbish, really, and kind of absent. And a lot of people were sort of, you know, really kind and patient and sort of like, oh, looking forward to what this is going to be. And kind of kept the faith that we would produce something of value, and I think we have, and we're just getting started. Really, we're still lots more to come. So yeah, just a massive thank you to all of you, and thanks for your patience. Thanks for being part of this kind of project, and thanks for, you know, tuning in and spending an hour or so of your Thursday watching this stream. So thanks.
Cool. Just quickly before we go, we're going to continue answering some of your questions on the comment section, and also we're going to compile them and then post it on our Slack community channel. So yeah, and we'll keep you updated on any future events. Yeah, thanks, Mel, for organizing this. So yeah, see you all soon then.
Bye.
Bye.